So this question involves the use of circle theorems. It's a start question, so they're looking for some clear workings out with explanations of why we chose all the bits we did. So we're going to start thinking about our circle theorem knowledge and the rules that we've got from that and the theorems. So what have they given us? They've told us that ABC points on the circumference. They're telling us that these two lines are exactly the same length. So the shape ACBT is a kite. And they're telling us that CA is, we've done that, and TA and TB are tangents. So straight away we can use the rule that TB and TA must be the same length because they're coming from the same fixed point and they're tangents to the same circle. So that might help us, and they're telling us that they are tangents. So that means that the radius point joined to B and the radius point joined to there, they are both 90 degrees, so that might help us. And we can already see here that we're getting a kite picture, so it looks like we might be using the angle at the centre is twice the angle at the circumference if we want to. So we're trying to prove that the angle ACB, so ACB, which is this angle here, we're trying to prove that that's 90 take away x, so it does look as if we're going to find that angle, and that must be twice the angle at the circumference. So we've got a kite here, AOBT, and we know this is 2x, we know that's 90 and 90, so therefore we can find the angle here because the angles in a kite add up to 360 degrees. So the first thing we can say is angles in the kite AOBT add up to 360 degrees. So therefore angle AOB must equal 360 minus 90 minus 90 take away 2x. Again, we can just point to those because it's asking us to prove. We ought to be putting in some more words. Tangents at A and B with the lines AO and AB, which are radii. Okay, so we know then that angle AOB is going to be 360 take away 180, so that's 180 degrees, take away 2x. Angle ACB equals a half of angle AOB. Again, it's proof, it's a start question, so we really ought to be writing down what the reason is. So angle subtended at the centre is twice the angle at the circumference. So angle ACB, which is the one we're trying to prove, is half of this angle, so we're doing a half of 180 degrees take away 2x, and when we do a half of 180 we get 90 degrees. Half of 2x is x, we're doing a takeaway, so we've shown that angle ACB must equal 90 take away x, which is what they wanted us to do. So we've done the question. Again, it's important, isn't it, that we've used the correct language and we've proved each stage of our workings by using the language of circle theorems and the angles in a kite